So we all know about Tesla's AI event, hugely anticipated and critically watched. I'll go ahead and say this. This was one of the most important events that happened in Tesla's history. It pushed Tesla beyond our wildest imagination and it blew away the entire auto industry and their competitors in dust. If Tesla was 5 years ahead, that's what we have heard in past, that Tesla is 5 years ahead of the competition. This event alone made Tesla 10 years ahead. If anybody is comparing, not sure who is anymore, but out there if anybody is comparing, this pushes Tesla 10 years ahead. Let me show you what I learned from the event, and I'll try to keep it very basic because if we understand the basics, then we can make our imagination run wild to understand the extreme. And we're starting right now. So the presentation started out with some basic slides, but the real meat of presentation was in what was said, not what was shown. With the little technical knowledge that I have, I can tell you this much, that this is a big freaking deal. And let me show you how. So I'm going to just show you the screen today because again, this is a slide heavy episode, so I'm not gonna share my camera. So as you can see, it started out with them saying that they're building a synthetic animal and a synthetic eye, and it displays right here that basically the information comes through these synthetic eyes and then it processed in brain, and then the neural nets come in and they do their part, and then the output is given to the computer. Now this is really cool. So he mentions over here, Andre, their AI lead mentioned that light hits artificial retina right here, the raw image comes in, it gets processed. If you look at the human brain, this is how it works. And then we make decision from our brain. Exactly happens the same way in the AI world or in Tesla's AI world. Then something was said which was really intriguing for me as a tech background, that they are basically doing it using C++. So C++ is a very old programming language, and I was really surprised. I learned C++ when I was in high school, and then when I came to college, I took some courses on C++. So C++ is a very basic programming, I would say, language, but very stable programming language. I mean, most of the huge or most of the large programs that today run on mainstream are basically made in C++. And if you can see over here, they are trying to depict the top-down pixel look. What it means is that the cameras are seeing the same image, but they have a different output of the image. One camera is seeing only this part. The other camera, the car is gone, if you see. The third camera is seeing the same image, but in a much wider angle. So then they take all these three and the output will be the same, or the result that the computer will generate will be the same. Then they take all three, put it in the neural net, and then tell the car how to perform. Now, this is really cool if you understand what's going on here. Like all three cameras looking at a same image from a different angle, then combining it all together to give a command to the vehicle on what it should do, which is really cool. Now, on top of that, then they talked about training their neural nets. Now, if you look over here, it says object detection, traffic light task, lane prediction. All three needs to work together in order for it to go into the neural net or into the brain of the car and then give the output of the car on how it should behave. Now, Elon said one thing which was really cool. Elon said that for humans, everything works very fast, but for computers, everything works very slow. See, humans, when we have to take an action, let's say if you're driving to a street, when we have to take an action, we really take an action based on our prediction. We don't know how many inches, how many centimeters, what is the total distance that I need to travel, what is the total angle I need to turn in order to make that turn or avoid that collision. But when we are talking about computers, all this is done in real time based on physics. So computers are very accurate to decide on, can I make it? Can I not make it? And because everything is running very slow for computers, they have the time to compute all that and then give the direction to the car in a way to go. Now over here it says multicam vector space prediction. Over here it says, okay, these are one camera. So right here, one camera, two camera, three camera. All that goes in to kind of generate this particular road that tells the car on how to go and what to do. It's basically taking three raw images and then going in and generating that one image that computer needs to understand. And this is all happening in real time. So this is massive and this is huge. Now they're talking about how they are generating or what kind of decisions are made by neural nets. So neural net makes the decision every 20 milliseconds to decide if the car is still there or gone. Because again, when the car is moving at one angle, the car or the camera sees the car, the second angle or the second it doesn't. 20 millisecond, it decides if the car is there or gone. then time-based cue and space-based cue prediction, and images from the neural net using all cameras. So right here, when the car is basically waiting at the intersection to make a left over here, then they are basically seeing all these cars move and then decides in 20 millisecond time-based cue and also the location-based cue or the space-based cue that, okay, can I turn? If I turn, then the car coming from this side, will it rear end me or not? If I turn, then the car standing over here, how long or what kind of speed I need to turn with. This is massive calculation happening in real time. They're solving huge problems. Give me any other company out there who are at this level solving this kind of problem. This is really exciting. And then on top, if you see over here, prediction and images from neural net using all cameras. So neural net is looking at this. Look, up the curb, the cross section, the oncoming traffic, the side traffic, and then deciding how the car should behave in the real map. I mean, they played a video. I was really impressed to see that video. So this is really massive. Again, I'm going to use the word massive. This is really massive deal right here. So then from there, they talk about the key problems, and this is where it gets really exciting. And they played a real video clip over here. So they're talking about two problems, non-convex and high dimensional. And then they played a visualization over here where the car was coming, the autopilot car was going from this direction, this car was coming first, then this car was coming, and how the autopilot decided that, you know what, it's my turn to go because I don't have a clearance or a way to stop, but these cars do. And this is all happening by keeping everyone in mind. That's what they said, that the visualization is happening by keeping everyone in mind or plan for everyone, not just for me, you know, okay, can I make it? I'm gonna go make it. No, it's seeing that if this car can make it or not. If we have more clearance, let's say if this truck was not parked there, I bet the autopilot will just go on the side and let this car pass because there is another car blocking the way of this car. So you can see how the car is planning for everyone, not just for itself. And then from there, this is what the car is looking. And this slide was really cool for me to see. So if I zoom in, you can see over here, these are the four major things that the car look for. And these are travel time, like what kind of, how many milliseconds or what kind of speed it needs to be in order to make that turn. Collision risk, like if the oncoming traffic is going to collide or not. Lateral acceleration, like what kind of acceleration is needed right at this point to make that turn. And then lateral jerk, if it brakes suddenly, then what kind of effect the car will have, again, by bumping into the cars coming from the back or from this side. So we are talking about true real-time calculation of right here, time, collision risk, acceleration, and jerk. Keeping all verticals in mind, the car is deciding how to proceed. This was really cool. Now they're talking about how they're training their neural nets with massive data sets right here. They're talking about that they have 1,000 data labelers within Tesla. True vertical integration, and how they talked about that first they were using a third party, and then they soon realized that the third party is not going to work for them because of the delays, because of they do not understand what Tesla is trying to do. So they basically hired 10,000 data labelers inside Tesla to work on labeling the data. So you know that they are very aggressively solving this world's biggest AI problem. In my opinion, this is one of the world's hardest tasks that they're doing. Then they showed this image of a before they had these neural nets, or before they had this high-powered AI into the FSD. They talk about the 2D image labeling. So the camera is seeing this in the car, and then it's labeling like, okay, it's a cone, it's a light, it's a stop sign right here, this is the line, these are the two lines I need to walk or go in. Then they talk about how that has changed now. Now the car is seeing all these images right here. So it's these 6 cameras. Along with that, the car is actually making sense of what's around it and what kind of cars are parked on the side, and what is the basically acceleration, as I mentioned in my previous slide over here, that they are basically labeling all this. Talked about here, travel time, collision risk, lateral accel, lateral jerk, all this is coming in play when they are now using the 4D space and the time labeling at the same time by putting it all together. On top of that, they are now doing auto labeling. Before they had this manual labeling where the people were coming in and they were labeling, okay, what this is. Now their neural nets are powerful enough to do auto labeling. 45 seconds to a minute for each clip to be auto labeled. And this goes then to the final AI to produce the final data labels. So all this work is happening before the AI computer actually knows, okay, this is a cone, or this is a road, or this is a lane. All this is happening behind the scenes, and then it's going to the AI computer or the neural nets to do the final data labels. So you see the accuracy or the time that they're taking to label each and every small part. See, you need to look at it this way. When we are going to a road, doesn't matter if the road is in Washington, D.C., doesn't matter if it's in Seattle, doesn't matter if it's in San Francisco, even though that the surrounding may be different, but the problem that the car has to solve are the same. Where is the curb? Where is the lane? Where is the pedestrian? Where is the light? Where is the oncoming traffic? All those is taken care of for it to produce. So when somebody asked that, what about other countries? Elon's reply was on point. See, we have to solve the problem somewhere first. Then we can branch out and start solving the problem in the other areas. All the roads in US follow the same traffic pattern. All the roads in US follow the same driving pattern. So it doesn't matter you are where you are. If you solve the problem in the US, then you can go and take that data labels or data sets and then start working on solving the other problem, which I'm going to show you next in the next slide that they mentioned. So then they talk about how different camera angles are capturing same information but differently right here. So this camera is looking at the same road, this camera is looking at the road from a different angle, and then basically they're labeling where's the curb, where is the lane, and where is the entrance, and where is the exit, all those things. Then from there the AI generates road labels and basically gives a bird eye view to the car to make sense of where the car is right now and where it wants to go, or what kind of intersection you are standing at right here. This is really powerful. From this, the neural nets and the AI is able to generate this. Massive deal if you ask me. And then from there, they're talking about mapping just cameras. Like, look at this slide. There is nothing going on there. There are no lanes, and this is probably not even US in my opinion. This is somewhere else. So from there, they can give that bird eye view to the car. Okay, these are all the walls. This is you cannot really go on this side. The car has to maintain few inches from there, few inches from there. So all this is happening without any marking, and the car is intelligent enough to understand what's going on here and where it needs to drive. This is really cool. And then the AI comes it all together and puts it all together to give the car this kind of views. Look, it's looking at all these cameras right here, the 8 cameras that the car has, and then from there it's basically generating this view right here. So you can see that this is all coming together so beautifully, and of course it's going to keep getting better as more and more training happens in their neural net. And then they talk about simulation. Now this was scary good for me, massive. Now the video when I saw first, I was like, this is real. The Cybertruck is on doing FSD. There is no driver involved whatsoever. But then they talk about how this is a simulation. This is really advanced simulation. And one of the best things that I got out of these slides, even though, it looked really beautiful of what they're trying to do here, is right here. They have 2,000 miles of road built for simulation. That's massive data set. Different objects, different shade, using different cameras, exposure, and then they're depicting the proper simulation. The lights, the weather, everything is kept in account when they are talking about simulation, and with the simulation, they can do so much. So they're talking about each and every scenario in their simulation before they perfect it for the real world, which is again a huge leap forward for a company like Tesla, because again, they have all this data to play with and to perfect their system. Then they talk about this beautiful slide, which was mind-blowing. So they are recreating failed autopilot and retraining neural nets with different outcomes. They talked about, because see, this is massive, as they are creating synthetic outcome using real data to train. And this is where I'm talking about that Tesla is almost now 10 years ahead of the competition, because they have so much data. They have so many robots on the road that is doing the work for them. On top of that, see, they got the data that something happened in autopilot. They took that data and they ran it through a simulation that, okay, if the car would have behaved in a certain way, then the accident would have not occurred right here. I'm just throwing it out that this is where it gets really, really cool and really exciting, that from each and every accident or each and every failed autopilot attempt, their computers are learning faster than human brains. And that's where the whole meat of the thing is, that this is really, really big deal. Then they talk about Project Dojo. And one of the things that I got out of Project Dojo is not how super cool the project itself, but their team. The guy who presented Project Dojo, you can just sense the excitement in his voice, that how huge the excitement was or what he was saying. I mean, this was really massive. One of the words that kind of stood out for me was that it's easy to scale the compute. You can add a lot of computers, but it's very difficult to scale the bandwidth and extremely difficult to reduce latency. And this is where Project Dojo comes in, where they kind of scale the bandwidth and reduce the latency at the same time. Because we have to understand, these calculation needs to happen in real time, faster than our brain can think. Then on top of that, they're talking about how they can super scale, and also they talked about this 9 teraflops in their hand. I mean, this was really mouth-salivating stuff for me. If I look at it, this was beautiful. And look how he's holding petaflops, not teraflops, 9 petaflops in the hand, just holding. And look at the excitement in the guy's face. I mean, this is a really big breakthrough in computing world. If you really just look at this one slide right here, this is massive breakthrough for computer world. Then on top of that, they're talking about how they're putting all these petaflops into an exapod, and then they're training their neural nets and their AI on top of that. I'm just so excited to say that this is all coming in live in front of our eyes within the last few years. I mean, if I take you back 5 years, was any of this possible? No. In 5 years, they are able to manage and do this, which I think in the next 5 years, you can imagine where they will be, because they are already talking about Dojo 2.0, where they are talking about training their neural nets even faster, or putting the more power in a small form factor and reducing the latency, which is a huge issue. So then we come to the point where everyone is getting so excited. I already saw a few articles on CNBC and few videos on CNBC about beyond vehicle fleet. So I feel Tesla, as Elon said, is the biggest robotics company, and they proved it yesterday very well that they are the biggest robotics company. And then they launched this humanoid or Tesla bot in a way which has all these things, which is basically we are talking about FSD hardware, Dojo training, auto labeling, simulation tools, multicam. I mean, everything that the car has, this one Tesla bot has. And then Elon talked about one of the few things that it can do. Prototype sometime next year. I won't hold my breath on it. It could be next 2 years maybe. Will be friendly, navigate through worlds for human for dangerous tasks. Also, he said that you can go to store and get me the following grocery, and I think we could do that. I mean, this is cool. Okay, then economy is the foundation of the labor. This was really a big statement. Where will the economy be if there is no shortages of labor? Just think about it in your head and let your imagination go wild here. Where would economy be if there is no shortage of labor? And then physical work will be of a choice, not, you don't have to do it. If you want to do it, sure, but it will be a choice. So when I saw this, two things came in my mind. Number one is that Tesla is leading the way in AI, in basically solving the world's most hardest problems. And we forget sometimes that they're doing something unimaginable, and the timelines that Elon gives, sometime a year or 2 years, or FSD will be ready in 2020 or 2022, we need to cut them some slack, because I feel they are solving the problem which they don't even know what kind of challenges they are going to face in the coming days, in the coming years, because nobody has done it before. The breakthroughs like this doesn't happen overnight. It doesn't happen in few years. It takes years and years of hard work to have a breakthrough, something like this, which a person basically running around and doing stuff for us. We have seen it in Hollywood movies, but this is real deal, and this is real stuff. I mean, why do you think that the person has a carry capacity of 45 pounds? Why do you think it can only lift 150 pounds when a machine can basically do everything? Because they don't want to overpower the humans by their bots, because he said you never know, right? So they are giving it enough power so that it doesn't overpower us humans. So after watching the event and after listening to some amazing questions, here is what I think is going to happen. Tesla is open to license its compute and AI power to other companies, which is a huge IP right there. I mean, Tesla stock is going to go ballistic if they start doing that. Number two, they are working at great speed to solve the world's greatest problem. Again, nobody else is doing it. There is no company in the world which is doing it. And again, I could sound like a big fanboy, which I am, but I feel Tesla is solving some massive problem. And number three, there is no one out there to catch up to Tesla. Just no one. So I did a whole video on Tesla AI Day back in April. Again, channel was very new at that time, where I kind of mentioned all these points that we might see from Tesla, and it all came true. I'll link that video here, so do check it out. Again, I apologize for the audio in advance. It was a very new video. And also, if you got anything out of the video, then please consider subscribing, hit the like button so we can go out and reach out to more Tesla lovers. As always, thank you for joining me. Love you all. Until next time, you all have a sparkling day.